Hi, boys and girls. Today's lesson is on real number families. This is lesson 2-3. Okay. Your I can statement is I can identify irrational numbers and name the sets of real numbers to which a given real number belongs. Vocabulary that you will learn, counterexample, irrational number, and real numbers. Are you excited? I'm excited. It's going to be super fun stuff. All right, get a break from the calculator anyway. Real numbers are numbers that can be found on the number line. I have talked about imaginary numbers before, like in the last section, I told you that if it was a negative number underneath the square root sign, that's imaginary. We're going to be talking only about real numbers, okay? Imaginary numbers are not real numbers. These are just the real ones. Watch the animation. Well, we can't really do that. All right. Real numbers are either rational with a decimal expansion that terminates or repeats, or irrational. An irrational number is a number that cannot be expressed as the ratio a over b, where a and b are integers. Oh my gosh, this is math textbook stuff. Okay, what it basically says is almost all the numbers you know and love are rational numbers. All right, the only ones that belong in the irrational number family are decimals that do not end and do not repeat. All right, one of the most famous ones, one of the most famous ones is pi. You all know that pi doesn't end and doesn't repeat. Okay, so anytime you take the square root of a number that is not a perfect square, you also get a non-terminating, non-repeating decimal. Those would be irrational numbers. We'll talk more about this. I made this great little graphic organizer for you. You can even color it in if you have colored pencils or markers. It should be available for you. Let me switch to pen, and I'm going to explain this to you. All right, back when you were little and your mom taught you how to count cookies and stuff, you used what we call natural numbers. Turn the pen on. Natural numbers were like your counting numbers. They start with 1, 2, 3, 4, and they go on from there. We didn't include 0. When you were 5, you didn't start with 0. You didn't even know 0 existed, okay? We didn't have any negatives, no fractions, just the counting numbers. But then when you went to school, you realized that really the number started with 0, okay? So the whole numbers are the natural numbers and 0. So if you take all of the counting numbers or the natural numbers, these are also called counting numbers sometimes. I will call them both. Counting numbers, natural numbers. Whole numbers are all of them and 0. The only difference between natural and whole is 0. Then you got, say about 4th grade, and we learned that there were negative numbers, okay? Integers are all of the whole numbers and their opposites, okay? So integers have all, let me say that over again. All of the whole numbers and their opposites. So we're talking like -2, -1, 0, 1, 2, and so on. What's not included in integers? What's not included is fractions and decimals. All right, it's all the positive numbers, 0, and all the negative whole numbers, but no fractions and no decimals. Rational numbers are where our fractions and decimals come in. Okay, fractions, decimals that end or repeat. Still haven't got the hang of this writing thing. So rational numbers are fractions and decimals that end or repeat. Those are called rational numbers. Irrational numbers are decimals that don't end and don't repeat. They don't end and they don't repeat. Some of your, one of the most famous ones, of course, is pi. Pi is an irrational number. Anytime you take the square root of a number that is not a perfect square, that is irrational. Now, I'm not going to put the square root of 4 here because the square root of 4 is 2. So that is rational. But the square root of 5 is not rational. The square root of 6 is not rational. The square root of 7 is not rational. If I were to put the square root of, say, 8 in a fraction, that's not rational, okay? In order to be a rational number, you have to be able to be written as a fraction. But there's a stipulation there. The top and the bottom, the numerator and the denominator, have to be integers. And the square root of 8 is not an integer. So in order to be rational, you have to be, all normal fractions are rational, okay? All normal fractions with an integer in the top and an integer in the bottom, say 3/4, those are both integers. That makes you rational, okay? If you have a decimal or a fraction that has a non-integer in it, it's not rational. It's irrational. And think of it this way, if it helps you remember it. When someone says you're acting irrationally, it's kind of like they don't know what to expect from you next. Well, with irrational numbers, it's the same thing. They're decimals, and we're not quite sure what to expect from them next. You know, I have pi memorized to 6 decimal places, but I don't quite know what it's going to do after that. And I don't know what it's going to do after that. It's acting irrationally. Okay? See if that helps you remember that. All right, so this is the graphic organizer that's in your course book. And this little paragraph down here says pretty much what I just told you. So we're not going to read that math mumbo jumbo. No, we are not. But they want us to write these numbers here in the right sections. All right, so -8. -8, well, it's negative. So that tells me that it is an integer, okay? -8 is an integer. It is not a whole number because whole numbers are only 0 and then the positive numbers. All right, integers are whole numbers and they're opposites. So -8 goes here as well as -3. Okay. Now, -3/4. There are no fractions or decimals in integer land. They don't get into that club, but they are rational. So -3/4 is rational, but it's not an integer. 0 belongs to the whole number club. Remember, whole numbers are just the natural numbers plus 0. 18%, now there's an odd one. Well, 18% can be written as 18/100. Since it can be written as a fraction, that makes it rational. So 18% lives in rational land. 0.4 repeating. Rational numbers are numbers that end or repeat. Because 0.4 repeats, it's a rational number. In fact, it can be written as a fraction. It's 4/9. Okay. 0.45. It terminates. It's just 0.45. It's equal to 45/100, which is a rational number. It's a regular old fraction. 1/2 is a regular old fraction. Ooh, there's our friend pi. He's irrational. We don't know what he's going to do next. And now this number here, this one is of particular interest to me. Students often think this is rational because they see it's making a pattern. Rational numbers don't do patterns, okay? It's 2, 1, 2, 3, 1, 2, 3, you know, it looks like it's going to be a pattern. 1, 2, 3, 4. This is, you got 1, 2, and then you have 1, 2, 3, and then 1, 2, 3, 4. And kids go, oh, it's a pattern, so I know what it's going to do next. No, this guy is irrational, okay? He does not get to go in the rational club. 1.2, 1, 2, 3, 1, 2, 3, 4, ... He's irrational. Okay, only repeating and terminating decimals are rational. Ones with funky patterns, no. Not a member of the club. Square root of 3. Ask yourself, is 3 a perfect square? If you answer yourself no, then the square root of 3 is irrational. If you don't believe me, you can put it in a calculator and it's going to go zinging across the screen because it does not end and it does not repeat. 4, 9, and 10 are all natural numbers. 4, 9, and 10. Those are the numbers that your mom taught you to count or Cookie Monster taught you how to count on Sesame Street when you were a little kid. Those are natural numbers. Okay. So, what do we have in store next? All right, determine whether negative 25 is rational or irrational. So this first part, we're really focusing more on, is it rational or is it irrational? Remember, irrational numbers are decimals that do not end and do not repeat. 25 looks like it ended, okay? They walk you through it. Can negative 25 be expressed as a word? This should be fraction, ratio. They want to make it sound smart. Can it be expressed as a fraction where a and b are both integers? Yes, it can, because we can write it as negative 25 over 1. So yes. When written in the form a over b, are a and b integers, which means b is not 0. You can't have a 0 in the denominator of a fraction. That's another imaginary number. Yes, it can be. A rational number is a number that can be expressed as the ratio of two integers. Since negative 25 equals negative 25 over 1, negative 25 is rational. Okay, so anytime they give you a fraction, as long as the top number and the bottom number are integers, it is rational. 2 and 9 are both integers, therefore this fraction is rational. Don't pay attention to the negatives. That has nothing to do with it. And, well, I say that. Negative numbers don't get into counting natural numbers, and they don't get into whole numbers. But anything else, negatives don't matter. Okay, name all the sets of numbers to which the real number 0.2525. Okay, now here's a repeater. This one's clearly repeating 25252525. All right, so can 2.2525 be expressed as a ratio in the form a over b where a and b are integers? Well, yes, it can. Okay, because 25 repeating is actually 25 over 99. You know how 9 repeats a single digit? 99 repeats a double digit. 99 and 99 are super fun. Is 0.2525 ... from the set of integers? No, it is not an integer, because in order to get in the integer club, you cannot be a fraction or a decimal. So 0.2525 ... is a rational number because it's equivalent to 25 over 99. Pretty cool. Okay. To which sets of numbers does the real number 21 over the square root of 4 belong? Now be careful. They're trying to trick you here with that square root of 4. They think they've taught you by now that square root is a red alert for an irrational number. But think about this. The square root of 4, isn't that equal to 2? It is. So this is really 21 over 2. Now, is that a whole number? No. That is not going to make a whole number. So not whole. But is it rational? It sure is. It can be written as a fraction. Irrational means it can't be written as a fraction. It's not irrational. It's not an integer, because an integer can't be a fraction or a decimal. It's not a whole number, and it's not a natural number. Okay? So it's only a rational number. Name all the sets of numbers to which the real number square root of 36 belongs. Is 36 a perfect square? Yes, it is. What is 36 equal to? 6. Can 36 be expressed as a ratio in the form a over b where a and b are integers and b is not 0? Heck yes, it can. It's 6 over 1. Is the square root of 36 from the set of integers? Heck yes, it is. 6 is an integer. Is it from the set of whole numbers? Yes, it is. When you were a little kid, it was a good day if you got 6 cookies. And is 36 from the set of natural numbers? Yes, it is. It belongs to a lot of clubs. Since the square root of 36 equals 6, it's a natural number, aka counting number, a whole number, an integer, and a rational number. It belongs to a lot of clubs. Very popular. To which sets of numbers does the real number negative square root of 64 belong? Okay, well, square root of 64 is 8, so this is equal to negative 8, okay? Is it rational? You betcha. I can write it as a fraction. It's rational. Is it irrational? No, you can't be both. If you're rational, you're not irrational. If you're irrational, you're not rational. So it's one or the other on those. Is it an integer? Yes, it is. Integers are all the positive and negative whole numbers. -8 is a negative whole number. Is it a whole number? No, there are no negatives in whole number land. Is it a natural number? Did you learn to count to -8 when you were a little kid? You did not. So it's only an integer and a rational number. Now we have negative square root of 7. 7 is not a perfect square. So that is irrational. Anytime you have the square root of not a perfect square, that is irrational. It is going to go zinging out. And if you're not sure, maybe you don't have all the perfect squares memorized, put in the calculator. You'll know right away that that's not rational. So does the decimal terminate or repeat? No, it will not. The square root of not a perfect square will not terminate, and it does not repeat. Can negative square root approximately equal to, they had to use the approximately equal to because this little puppy goes on and on and on, okay? Can it be expressed as a ratio in the form of a over b? Nope. The decimal value of negative square root of 7 neither terminates nor repeats, so it is irrational. Square root of any number that's not a perfect square is irrational. To which sets of numbers does the real number pi belong? I remember I told you pi is probably the most famous irrational number on the planet. And because it's irrational, it is none of those other things. All right? It's a real number, but it's not rational. It's not an integer. It's not a whole number, and it's not a natural number. No. Okay. Now they want to do things like all whole numbers are integers and things like that. So this is what this next section is about. Some sets of numbers are subsets of other sets of numbers. And you know that already because when we had a number like -8, it got into lots of clubs, you know. So -8 can belong to several sets of numbers, okay? And then when you have something like an irrational number, it only gets in one club and that's it. So basically what they're saying is use this Venn diagram to make huge statements about rational numbers. So let's see, what has it got going on over here? They want us to watch this animation, which we're not doing. Watch the animation or use the Venn diagram to complete the following sentences. Blank numbers are a subset of whole numbers, okay? Subset means they're a smaller set inside of whole numbers. What's a smaller set inside of whole numbers? That's, oh, I turned off my pen. That would be your natural numbers. They are a smaller set inside whole numbers, so that makes them a subset. Blank numbers are subsets of integers, okay? What's a smaller group of numbers inside integers? Well, that would be your whole numbers. Whole numbers are subsets of integers. And actually, you could say whole and natural. They're both subsets. Integers are a subset of, well, integers are contained within the realm of rational numbers. Rational numbers and irrational numbers are subsets of the real, don't fail me now, pen, of the real numbers, okay? This whole box is real numbers. You won't learn about imaginary numbers until high school. All the numbers that you know and love for most of your life have been real numbers. The thing is, these irrational guys over here are like the outcasts of the number world. All right. All these other guys over here are hanging out in their little clubs and stuff. And irrational numbers, it's like, ooh, no, cooties. You stay over there. Okay. So here's a vocabulary term for you. If a given statement about real numbers is false, you can provide a counterexample, which is a statement or example that shows a conjecture is false. And I will help you form counterexamples. Okay, use the Venn diagram to determine whether the statement is true or false. If we say false, we have to give a counterexample. All rational numbers are integers. Well, we look at this graph, the graphic organizer over here. Rational numbers, these ones that are out here, are not in the integer family. Okay, so this is false. Can we think of a rational number that's not an integer? You betcha. Any fraction is not well, I can't say any fraction, because if we used a fraction like 6/1, that is an integer because it's equal to 6. But if we use a fraction like 2/3, that is not equal to any whole number. So that one is a set of rational, but not integers. It's rational, but it's not an integer. That is an example of a counterexample, because I was able to find a number that was rational, but did not belong to the integer family. Determine whether the statement is true or false. Integers are a subset of rational numbers. Okay, I'm trying not to cheat off the teacher edition here. Sometimes it's hard to tell what they want in these blanks. Provide a counterexample. All right, one possible counterexample is 0.6. 0.6 is rational, but it's not an integer. So they went with the decimal counterexample. Here's your check. Use the Venn diagram to determine whether the statement is true or false. If the statement is blah, blah, blah. All whole numbers are natural numbers. So they're saying that all the whole numbers are natural numbers. You know, the one difference is natural numbers don't have 0. Whole numbers have 0. So it actually is false, because 0 is a whole number that is not a natural number. That's our counterexample. There's only one, but it's enough to make it false. Oh, what do I do now? Go away. Okay. All right. Moving on. All irrational numbers are real. All irrational numbers are real. Well, let's look at this. This is the box of real numbers. Are all the irrational numbers in the box? Yep, they are. So, by definition, irrational numbers are a subset of real numbers. So, irrational numbers are real numbers, and the statement is true. I don't know about you, but I kind of hated this part of math when I was a kid. It's not my favorite. I like to solve for x. Okay. All natural numbers are whole numbers. If natural numbers is a subset, it's contained within whole numbers, then all natural numbers are whole numbers. All whole numbers are integers, okay? All integers are rational, all right? If it's a subset, then that means all of them belong to that club. So, is the statement true or false? It's true. All natural numbers are whole numbers. And I just explained my reasoning. I'm not going to write it, because who wants to watch me write with this stupid thing? All right, and that brings us to our practice problems, which is a different video. All right, so I hope you had a great time. I know I did. Super fun learning about the number families. I got a couple of cool videos for you. I'll show you in class. And you guys have a great day. And you know what I almost forgot? The secret word of the day, or the video. For the video question, the secret word is turkey. So go on over to McGraw-Hill and pull up the 2, 3 real numbers video question and answer turkey. Love me some turkey. All right, you guys have a great day.